Great seeing you in this new video. In the previous lessons and a few lessons ago, we were defining the different estimates at completion, and we found some very interesting parameters, and we looked at the different estimates and we named them optimistic, probable, and pessimistic estimates. And I asked the question, why don't we in fact introduce PERT and 3-point estimates to earned value management? And what we're going to do here, we are going to add probability to the different estimates. When we look at earned value management or the earned value analysis, and we look at the experience from the people using it, the industrial experiences, we know that it's a very trustworthy system. Of course, we have those optimistic, probable, and pessimistic estimates that we defined in the previous lessons, and we were thinking about using the probability curves for these applications. So we're looking at the probability curves, and we can look at the probability and cost and profit. Let's look at earned value management and some experiences that we can recognize. And when we look at earned value management or earned value analysis, it has a proven track record, and many companies in project management are using it, and in certain state-led projects, they must even use earned value management or EVA. So it's sometimes a must to use it. Some companies also want the project team to use earned value management. Unfortunately, there are still a lot of people who don't want to use it, who don't use earned value management. I understand it's a little bit more complicated. You have some formulas, you have some calculations, but it's not rocket science, That would be another course I could be teaching about rocket science. These are simple mathematical principles. Of course, we must be careful when we are using earned value management, and we look at the different items. And when we look at earned value management, we already discussed that the schedule information is not so interesting. It doesn't really show some very good results, prognosis that we can take, but we can use the earned value management related to the estimates at completion about the costs. That's more reliable. Now, when we look at everything that we did before, we were talking about the optimistic, the probable, and the pessimistic estimates. So when we define those estimates, when we looked at the estimates at completion, we also considered that the mathematical estimate was an optimistic estimate. An optimistic estimate, which means, we are going to continue the remainder of the project as we budgeted it. That's kind of an optimistic idea, certainly when we are having, let's say, when we are overspending on the project. So typically, this is what we would call the optimistic estimate. The CPI-based estimate is also referred to as a probable estimate. We would also call this the mode. So in the most cases, this is the output we would expect. And it's also based on the fact that we are continuing the CPI, the financial efficiency that we had before, and we're happy to work like that. So we're just continuing the tendency that we have. And the last one, the CSI-based estimate, here we look at the total view of the project. We are multiplying the CPI with the CSI, and what we get here is that we are in fact adding all the elements together. The CSI is typically a lot smaller than the CPI because we also multiply the CPI with the SPI, and we consider this as a pessimistic estimate. So we're looking at both elements together, schedule and the cost position. Based on these definitions, I assumed, why don't we use the PERT and the 3-point formulas for this? because we can use or we can assume that we have either a beta distribution or a triangular distribution related to the cost spending over the duration of the project. And of course, we can use the probability curves here. We can look at those probability curves, and when we calculate the expected outcomes using the 3-point estimation technique, we obtain in that case the expected cost or cost with a probability of 50%, and the other output of the formula is the standard deviation. So we have two parameters that allows us to build or to use it with a normal distribution. And we could also use it with a PERT distribution, a beta distribution or a triangular distribution. That would also be a possibility, but everybody is used to using this with a normal distribution, and that's a very interesting way to work with it. Now, when we look at the different elements, we have used this information to draw a probability curve. And the probability curve is a link between the duration and probability. And now we are going to do that. We are going to use the same thing to create a probability distribution between a cost and a probability. So we will have an S-curve, and based on that S-curve, we have a probability curve where we can estimate what is the probability that the total cost of the project at completion will be less than a certain amount. When we have the three estimates, and like I said, we're going to use the same technique as we did with the probability curve of the duration that we already did before in some other project, or that you may have seen in some other course. Now, when we look at the probability, is in fact the next thing is to look at the cost and the profit. You have to understand that when we do a project, we want to create a value, and a value is or can be expressed as a financial value, a financial cost, and a profit and loss. So the goal of the project is to realize that value. And when we look at the value in our case, when we look at value management, we will be looking at cost and profit. And what we want to do, we want to find or we want to compare the final cost of the project with the business case parameters, for example, the payback time, the net present value, and the internal rate of return. And when we are looking at a statement of work, a contract with a third party, we try to reduce our costs so that we can guarantee our profit. When we look also at the project execution and when we make decisions, we also can evaluate here how the project is doing and make the right decision. And in certain cases, when we see that our prognosis are, let's say, so much out of line, we can even kill the project when we assume or we are sure that the project will not be profitable. We don't want to have or finish work on projects that will not be profitable, because then it will be a loss, and that's not good for the organization. When we understand the cost profile, it is possible to evaluate the profit over the project life cycle. So we can identify, once we know the estimates at completion and with a certain probability, what we can expect here. So that was an introduction about PERT and 3-point, and how we are going to use the 3-point estimates together with our estimates at completion. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.